All right, everyone. So this video is going to go along with the front page of the 3.1b notes on graphing polynomial functions. Okay, this is part one of these notes. We're going to talk about end behavior first, and then we'll talk about how to graph the in-between part of the function. So the end behavior will be the first thing we look at. Okay, there's four situations that we're going to need to determine first. We've got two even degree functions. Okay, we just went over degrees of polynomials. If the first term has an even exponent, like 4 here and like 6 here, that'd be considered an even degree function. And those are going to behave just like the basic parabolas, those quadratic functions that you've graphed previously. Okay, so we're going to determine what's going to happen as we approach negative infinity to the left. Okay, as x gets smaller and smaller and smaller, what's going to happen to this graph? And we're going to think about what happens to the function as x approaches positive infinity. Okay, so with even degree functions, if we've got a leading coefficient that's positive, again, you want to think back to your quadratic function unit. If the leading coefficient is positive, we said the parabola opened up. Okay, so on the end, as x approaches negative infinity, y would approach positive infinity. Okay, on the right extreme over here, as x gets bigger and bigger and bigger, y is going to continue to do the same thing. It's going to approach positive infinity as well. Okay, again, think about the quadratics. The parabola opens up if the leading coefficient was positive. Okay, what's going to happen in the middle here, we're going to determine. There's a lot of different things we have to do to determine what happens in there, but we'll deal with that later. Okay. Second, we've got an even degree function, 6th degree function here. The leading coefficient is -2. So just like with parabolas, if you've got a negative coefficient, we would say it opens down. Okay, so as x approaches negative infinity, y does the same. As x approaches positive infinity, y approaches negative infinity. Okay. With odd degree functions, it's going to be a little bit different. We just graphed some cubic functions in our last unit. They had different end behaviors. All right, so this is an odd degree function with a positive leading coefficient. So as x approaches negative infinity, y will do the same. Y is also going to approach negative infinity. All right, as x gets bigger and bigger and bigger, as x approaches positive infinity, then y is going to do the same. Y is going to approach positive infinity. Okay. So that's an odd degree function with a positive leading coefficient. Again, what's going to happen in the middle here, we're going to find x-intercepts, we're going to find y-intercepts, we're going to find different values to help us graph what happens in between there. But right now we're just dealing with end behavior. If we've got an odd degree function and a negative leading coefficient, we're just going to reverse that. As x approaches negative infinity, y approaches positive infinity. Okay. And as x gets bigger and bigger and bigger, as x approaches positive infinity, y is going to approach negative infinity. Okay, so that's how we determine end behavior. You're going to look at the degree, you're going to look at the leading coefficient, and that's going to tell you what happens as x approaches negative infinity and x approaches positive infinity. Okay, right now, if you would, pause the video. We want to try these 4 problems that are on the notes page. All right, hopefully you've tried those, hopefully you had some success. With practice problem number 7 here, we've got an even degree polynomial function with a positive leading coefficient. So the end behavior should look like this. Okay. All right. In number 8, we've got an odd degree polynomial function with a negative leading coefficient. So the end behavior should look like this. In number 9, we've got an odd degree polynomial with a positive leading coefficient. So the end behavior should look like this. And number 10, we've got an even degree polynomial function with a negative leading coefficient. So the end behavior should look like this. All right, hope that helps. I'll talk to you guys soon.